Okay, a very good morning to all the participants, my beloved students and my colleagues. Welcome to the Department of Electronics and Instrumentation Engineering, Gurunanak Institute of Technology under the JIS group. Today, the team team Electronics and Instrumentation JNIT is here to present all the hands-on experiment on the virtual platform. Okay, so I will just brief you about the department. That is, this department has established in 2003, and the basic subjects that this department covered, that is the automation engineering. You have heard about the term automation. Basically, automation is the heart of this course, and in today's situation, we can think anything, any system without automation. Okay, so besides the automation, basically the engineers getting skilled in the area of sensor applications, sensor networks, then Internet of Things, that is IoT, then microcontroller, microcontroller based systems, then the designing tools, and as well as the core subjects, that is process control system. There are several computer languages are also being taught there. And one thing I want to mention you that from 2003 we have started this department. There are several alumni and several students. They are basically distributed all over the India, rather all over the world also, and they are placed in several reputed institute and organization, such as in different PSUs, that is the power generation sectors, that is NTPC. You have heard about that, IOCL, then GAIL, SAIL, VAIL. And besides these core sectors, every year students getting job in the IT sectors also, that is TCS, CTS, Capgemini, these all the IT sectors, and they got the job during the campus interviews. Okay, and there is another aspect, that is the gate examination. I think you have heard, that is with the teachers always guide the students for this gate examination, and every year students getting good percentile in the gate examination. Okay, and through the gate examination, not only the higher study, students are also getting the jobs directly absorbed in the PSU. And one thing is that we have well-equipped laboratory, we have centralized library and the departmental library also. And now these pandemic situations, we have started our online classes from the middle of the March. And today's program motto is that students, you thought that is these are the engineering, those require the high-end labs, and we have to go to college and we have to do these all experiments during these pandemic situations. But one thing that we the teachers and the technical assistants today will share, that you can also do the all experiments, all the technical jobs on the virtual platform, sitting at your home from your own system. Okay, that is our motto. And basically after the end of this program, I will come back again to discuss your views and you share your views. Now I will not take much more time. Okay, and we will now enter into the virtual lab of our department. Okay, so I would like to request Shuparna ma'am to continue the program, and all the best. My best wishes is always for you. Okay, thank you.
So now I would like to request all the members of our department to come through a webcam. Welcome all the participants. So students, here we, 1 minute. So students, here we all present from our department with the teachers of EI department of JNIT and technical assistants. So now we will move to the main program. So all of you are requested to switch off your microphone as well as webcam.
Thank you.
So now we are going to virtual laboratory of our department. Students, we have in our department 6 well-equipped laboratories, and these laboratories consist of different instruments which are as per the modern instrument used in different plants. And these laboratories also have some softwares. So considering this pandemic situation, we transformed all the laboratories in virtual mode. Our departmental teachers, technical assistants, and some of our students are here to demonstrate these laboratories and some projects also. So after each and every laboratory, you will get the link of software through which you can also do the experiment anytime sitting at home. Okay, let's start that virtual laboratory. So first of all, I would like to call Dr. Paramita Banerjee to demonstrate the digital laboratory. Over to Paramita, madam.
A very good morning to all of you present over here. So am I audible right now?
Yes, Paramita, you are audible.
Okay. So a very good morning to all of you present over here. So students, today we have gathered here for the reason to explain that how all the education system can be shifted to the online platform considering the need of the society. Nowadays, we are going through a very tough situation. So in this situation, it is not expected that always we have to go to the class or the laboratory to learn the things. As well, it is also necessary to not to stop the study. Okay, the education should continue whatever is the situation. So we, the teachers, has the responsibility to learn our students that how to conduct all the education system, all the laboratories, everything in the virtual platform. So today we are here to demonstrate you that how we can conduct all the labs in the virtual platform. So students, let me share my screen now, and we are going to show you that how the circuits can be made in a online platform instead of going to the college and designing the circuit, hardware circuit rather. So is my screen visible to you, students? Is my screen visible to you?
Okay.
Yes, ma'am.
Okay. So we know that in our recent world, we all understand the automation. This term is very much clear to, is very much known to us, and our department is dedicated for these automation technologies. So whatever is there, whatever automation is there, the background is the digital world. So today I am going to show you small digital circuits that how we can perform the digital activities in the simulations also. So students, this first circuit explains, this is the circuit to explain addition. As you are students of class 2, so if I go to more complicated technical topics, then it will be difficult for you to understand. That's why I am trying to describe these topics in a very simple manner, and the things which are known to you. Okay, so we all know that the addition, that means if I add 0, 0, then the result will be 0. See, I have taken two input numbers 0 and 0. So if I add them, then the result is 0. If any one of the number becomes 1, then obviously the result will be 1, but the carry will be 0. If we make all of the input, that is that both of the inputs are 1, then 1, 1, if I add 1, 1 in digital, then the result will be 1, 0. That means 0 will be the result and 1 will be the carry. So you can see that in this particular circuit, this particular LED has gone off and this particular LED is on. It is indicating that this is the addition of 1 and 1, where the result is 0 and the carry is 1. So similarly, if we change this input, see the input values has the output LEDs are changing. If one single 1 is there, then the result will be 1. If both of the inputs are 1, then the result will be 0, but the carry will be 1. So this is a very basic circuitry to explain that how we can simulate this. So students, if I simulate this circuit, then any kind of digital circuits we will be able to simulate. Okay. Now next thing, you can see that you are very much familiar with the 7-segment display. Wherever we go in the platform, in the traffic signals, or anywhere, we can see a display that is known as 7-segment display. I don't know whether you are familiar with this, but you most probably you are familiar with this kind of displays. See, here I have displayed AEIE. That is the name of our department. So you can change these connections. If I change this connection, see, this has converted into 9. Okay, if I make the another connections on, then this will be 8. So using this particular way, we can display anything, whatever we want. So I am giving a very small explanation for your understanding, because you are class 2 students, so it is not very much possible for you to understand the more difficult technical topics. But students, you can very much understand that if I can simulate these small things using the simulators, online simulators, then we will be able to design any difficult circuit using the simulators also. See, you are at your home, I am in my home, and from our home comfort, I can communicate with you like this simulator platforms. So students, the technology has allowed us to communicate with our students in the online platform, because the education should not stop, and it always is not based on the computer based subjects. We can implement the hardware things in the simulations also, and that's the technological advancement. Okay, thank you students. Thank you all for your patience listening. Thank you all.
Thank you, Paramita. Students, if you have any query, then you may ask us.
Another thing, I am sharing this link with you in the chat box so that you can try at your home also. Okay, students, so I am sharing the link here in the chat box, the simulator link which I have used to demonstrate the lab, so that you can easily use it at your home.
So students, go through the chat box. You can copy that link and you can save this one. And in future, you can use also this one. Okay. So now, demonstration of analog electronics laboratory will be given by Mrs. Shantana Das, faculty member of AI department. Madam, please.
Shantana ma'am, please unmute yourself. Please unmute yourself.
Am I audible?
Yes, yes, yes.
Am I visible?
Yes.
Yes.
Very good morning to all of you, my dear participants. So today we have one objective now, how to get the online labs to access, right? So here I am present in the analog lab, and that is designed, basically that is virtual lab designed by IIT Kharagpur. And we will be designing today on hand, that you can also design. I am sharing the link here parallelly with me. That is the amplifier. This one is very much versatile. Whenever we are basically implementing any kind of designing of the amplifier, that will be used in FM and M, that is very versatile, and that will be utilized over here. So I am designing here the analog amplifier with a specific bandwidth. That is very much important, right? So you can parallelly do with me. Let's move on to directly to the topic, that is the amplifier design, and we will be using the virtual lab designed by the IIT Kharagpur. Okay, so let's move on. I'm sharing the link here. Now let me share my screen. Allow me a few minutes. My screen is visible. Is it visible one?
Yes. Yes, it is visible.
Okay. See, we'll be designing the amplifier, right? So you know the transistor now, and you know a little bit amplifier, right? And all the resistances I have connected, that is according to the design purpose. And you don't know very much, I think, as because you are just 10 plus 2 level. So that's why I am not going to the detail into it. But I'm trying to just give you a glimpse how to design the amplifier with a proper value. That is main concern, right? So that's why we will be using here the resistances, all the resistances. See, RS, RB1, RB2, RC, RE. Those are all the connected, externally connected resistances, as well as all the capacitors, right? Along with the load resistance. And we will be varying the frequency, okay, with a very minimum value to a maximum value. And we will try to get that how the amplifier actually amplifying the signal with the respective frequencies. Okay, let's see, let's design the amplifier. Okay, so that's why we will be choosing all the resistances and the capacitors value. Let's see. So I have chosen here RS, that is the source impedance, that is quite 400 ohm, right? It is in ohm length that is shown. Okay. Now the collector resistance. So we will be observing this one is the collector resistance. It is near about 3.5 kilo ohm, right? And the emitter resistance over there, and that is your suppose it is 1 kilo ohm near about, and your RL you are choosing here. Absolute value we are choosing, that is the maximum value here is given, and then best resistance we will be choosing over there. Okay. Similarly, we are choosing all the capacitors value. See, all the values are set now, right? Now it is now time to take the readings. Okay. So we will be actually changing the frequency, and we will be getting certain the gain. Okay, and that will be plotted. And then from where we can calculate what will be the lower limit of frequency that we can pass, as well as the higher limit of frequency that we can pass. Okay, so that's why I am choosing the lowest range of frequency first, and that is suppose it is 50. Okay, now we will be adding the we will be simulating the circuit, and we will be getting the added recording. Okay, say add to the table if we put, so what we will get? We will get here the 50 hertz frequency, that is giving the magnitude in dB. Okay, dB means decibel. So whatever be the values coming, that is V output divided by V input voltage, that we have fixed to 1 volt. So V output by V input, that will be taken into log scale to the base 10 and then multiplied with 20. That will give you the magnitude in dB. Okay, so 20 log of gain to the base 10, right? That's actually the log base, right? So we are varying the frequency in a different manner, and we are adding the records in the table. So it will be continued, right? It will be continued. We are varying the frequency, we are getting the gain, we are varying the frequency, and as well as we are getting the gain. So respective gain and frequency versus gain will be plotted now, right? So it is quite about the completion of the table. Now we are plotting the records. See what we got there. This is basically the gain versus frequency that is showing the graph. Is it visible? This graph is visible to you. Anybody please respond from my student side.
Yes, ma'am, visible. Yes, ma'am.
So it is basically called the frequency response, frequency versus magnitude, right? So here we can understand, see, with those frequency ranges, lower range of frequency, we are getting basically the magnitude is not so good, right? Similarly for the higher range of frequencies also.
Miss, what is the name of the graph?
Name of the graph is frequency response, right? That
Oh,
means
sure.
whatever be the frequency with respect to gain, we are getting in dB. dB means 20 log of the gain, right? It is not actually linear scale, right? Actually, what we have here, we have to accommodate so much number of frequencies starting from very low value to a high value. That's why I am taking the log, right? So to accommodate the huge range of frequency. So that's why that is coming from the lower range, hertz range towards the megahertz range, right? So that's why this actually plotting is called frequency response. So we are getting here magnitude versus frequency graph, from where we can easily understand that here the gain is not so good, and for the high range also we are not getting the gain is not so good, right? So that's why we will not be choosing the frequency that is just besides 1 kilohertz, okay, lower level of 1 kilohertz, and then higher level up to megahertz we can consider, that is quite 500 kilohertz, and it is showing near about lower for the frequency that is of the range 6.6 kilohertz, and the higher range that is 3 point something megahertz, okay, 3 near about 3.5 gigahertz. Okay, so it is all about the bandwidth of the frequency. So in that, that bandwidth of the amplifier that we have decided, right? So in this way we can proceed. So you can do parallelly also. Okay, so is it okay now? And are you doing parallelly with me? Or you can do it just after this session also. So thank you all.
Thank you, madam. Students, do you have any query? If you have any query, you may ask now, or you can write down your query in chat box also. I think there is no query. Ma'am has explained very clearly. So now we will see how to do the program on microprocessors virtually. I know that you all know a little bit of processor. So our technical assistant Navamita Pal is here to explain how to do the program on microprocessors. Okay, Navamita, please.
Hello, am I audible?
Yes, Shantana madam, please stop
Hello?
presenting. Shantanu madam, stop presenting. Yes, Navamita, you are
Stop
audible.
presenting. Okay.
Okay, I am
Good morning.
taking the questions and I am answering the question in chat box. Okay, I'm trying.
Okay. Good morning, participants. First of all, I discuss about how to execute the 8085 microprocessor programming on simulator. Using this simulator, instead of going to college, at this situation, we can execute any kind of program. After the execution, I will share the link. Is it visible? Is it visible?
Yes, Navamita, it is visible.
Thank you. This is the link sim8085.com is the link. sim8085.com is the link of 80 to run the microprocessor programming. First of all, we write down the program. By using a small simple program, we can see how to execute the program using this simulator. Okay, first we can start a sample program. This is the addition program. Okay, first start the program. Start. Then we can write mvi b comma 04 hex, means 04 hex data is loaded immediately to B register. After that, MVI C, comma 06 hex, means the 06 hex data is immediately loaded to C register. After that, move A, comma B, means the content of B register is stored in the accumulator, because accumulator is a temporary register and any operation is held in the accumulator. After that, add C, means the content of accumulator is added to the content of C register, and it is temporarily stored in the accumulator. After that, we move to the result part, which is stored in the accumulator, to the D register. That is move D, comma A. Okay. Then the result will be stored in D register. After that, halt. Halt means end the program. After writing the program, we assemble or compile the program through this. Then the hex code is generated. After that, we can see BC register, DE register, HL register here. So after the execution of the program, we can the input of registers and the output of the in registers. We can run the program. After that, in B and C register, we take the input 04 and 06. After the execution of the program, in accumulator and D register, store the result. In D register, store the result 04 plus 06, that is 0A. And in accumulator, also store the result 0A. This is the programming part of 8085 trainer kit. Now I discuss about some application of 8085 trainer kit. That is the interfacing. First, I discuss about the traffic light controller, interfacing of traffic light controller with 8085 trainer kit. How to operate the traffic light controller through the programming of 8085. Now we can see.
This is 8085 trainer.
Is this audible and visible? Ma'am, please.
Yes, ma'am.
Yes, it is audible.
Okay, thank you.
And this is traffic light controller study card. And the traffic light controller study card is interfacing with 8085 trainer kit.
Students, this is one laboratory setup.
26
I am explaining now.
This is the power connector of this study card, and this is the power connector of this 8085 trainer kit. The both are operated at 0 to 5 volt DC power supply. The traffic light simulator interface module, which can be used with this trainer kit, is designed to simulate the function of a four-way traffic light controller. Combination of red, green, amber are provided to indicate halt, wait, and go signals for vehicles. Then red is for wait, halt, green, amber is for wait, and green is for go signal. This is the trainer kit where the program is already installed. Now I execute the program, and after that the traffic light changes to its own system. Reset, go, 8020, execution. It changes. Then this direction is on. The vehicles go through this direction. The remaining direction is off. This is, and it changes the direction. It changes the direction, then the direction is on and the remaining direction is off. This is amber.
I request Tina Maji to stop presenting.
Hello.
Now start presenting again.
Okay, thank you.
Okay.
Is it audible?
Yes, yes.
Okay.
Yes, it is audible.
No, ma'am, it's not audible.
Navamita, unmute your video.
Okay. Hello.
Navamita, unmute your video. Video sound is not audible. Navamita, it is still not audible.
Is it audible and visible?
No.
Okay.
Off and this side is open.
Is it okay?
This is the
Okay. Sorry for the problem.
four-way traffic light controller. Four-way traffic light controller. One way is for go condition, one is wait, and the other two is halt.
These students, is there any confusion? Sorry for the problem. And this is the traffic light controller interfacing with 8085 trainer kit. We execute the program through 8085 trainer kit, and we see the direction, the changes of direction of traffic light through an interval of time. Now we can see the elevator. We can see another implementation, which is elevator, interfacing of elevator with 8085 trainer kit.
Yes, student, we send this video through your mail. Okay. We have your mail ID. We will send that video through your mail. Okay.
Navamita, you are not audible. Navamita?
Yes.
You are not audible.
Okay.
And it is not visible also.
Okay.
If you face any problem, then you can carry on our next experiment. You will present in the next. Now it is okay. You carry on.
Student, this is my 8085 microprocessor trainer kit, and this is an elevator study card. This is elevator study card. We are interfacing this elevator study card to this 8085 microprocessor trainer kit through this cable, through this 26-pin cable. This is the power connector. This is the power connector of the study card, and this is the power connector of the 8085 trainer kit. The both are operated at 0 to 5 volt DC supply. An elevator control and operation of an elevator functioning within a building having four floors is simulated by this interface. We say this is the fourth floor simulated in this interfacing. A, T and a corresponding LED indicator serve as a request button, and the request status indicator, a row of LEDs indicate the position of the elevator within the shaft. A row of LED is the position of the shaft. And when after the execution of the program, the green LED indicates where the elevator is present. When the light indicates, green LED indicates that the elevator is at the floor. When we execute the program, reset go F000 and execution. Then we see that the LED shows, the green LED shows that it is at the ground floor. That is in switch 1, it is in the ground floor. When we request this for this second floor, it goes to the second floor. When it reaches to this position, it stops. After that, when we wish to reach this in second floor, then it goes to this position. After that, when we wish to get in fourth floor, it goes to this position. It goes to this position. After that, at the last, we lift it down to the elevator to the ground floor. Then it indicates to the ground floor position. This is the function of elevator.
Dear students, have you any question or query about this two system interfacing with the 8085 trainer kit, that is traffic light controller and a elevator? Is
Ma'am,
there any question?
yes,
Yes.
what is the name of that programming language that you used while casting the screen in the beginning of the lecture?
This is 8085 microprocessor assembly high level assembly language based programming.
Was that a programming language?
Yes, it is a program language. Microprocessor is 8085 microprocessor programming language.
Okay.
Okay. Any query or question from participants, please? Okay, then I will share the link through which we can execute any kind of 8085 programming on chat. I can share this on chat box. Okay, thank you. Is there any question? Please write on chat box. Thank you.
Thank you, Namamita, for your nice explanation. So now we will see the virtual laboratory of sensor application, and it will be demonstrated by Mrinmoy Dattu, technical assistant of our department. Mrinmoy, please.
Thank you, Shubhanadi. Good morning, participants. Myself, Mrinmoy Dattu, technical assistant of Applied Electronics and Instrumentation department. Basically, we done our different type of lab experiment in our laboratory, like temperature measurement, level measurement, flow rate measurement, pressure measurement, etc. But now in this scenario, we use virtual platform to demonstrate and simulate this experiment. Now we demonstrate and simulate two experiments. One is temperature measurement using RTD and another is temperature measurement using thermocouple. Is it visible?
No. Yes, Mrinmoy, it is visible.
Okay. So this is our experimental setup which we used in our laboratory. In this setup, we done both of our experiment, that is by using RTD and thermocouple, we also measure the inside temperature of muffle furnace. This is the muffle furnace, and this is the display, digital display part of thermocouple, K-type thermocouple and RTD. Okay, so now we define the working principle of RTD and thermocouple. That is, the RTD stands for resistance temperature detector, which operates on the principle that the resistance of a metal changes predictably in and essentially linear with the change in the temperature. RTD has a positive temperature coefficient. That means the resistance of a RTD increases with increasing temperature. So this is the working principle of RTD. And the working principle of thermocouple depends on the thermoelectric effect. If two ends of two dissimilar metal are joined together so as to form a closed circuit, there will be two junctions where they meet each other. If one of the junctions is heated, then a current flow in the circuit, which can be detected by a galvanometer. The amount of a current produced depends on the difference in temperature between two junctions and the character of the two metals. This is known as Seebeck effect. Now we go to the simulation part. At first, we demonstrate by using simulator how to measure the temperature using RTD. Is it visible?
Yes, Rinma, it is visible.
Okay, thank you. There are two parts in this simulator. One is static characteristics of RTD and another is dynamic characteristics of RTD. So this is the static characteristics. At first, we just select the material of RTD, that is platinum. After selecting this, here also show the value of alpha, that is 0.00385, and the temperature range is -200 to 850 degrees centigrade. Then we select the value of R0, that is 100 ohm. R0 means at 0 degree centigrade, the value of resistance is 100 ohm. Then click get temperature, that is -146 degree centigrade. Then by applying the formula, that is RT equals to R0 1 plus alpha T, we also get the value of resistance at T degree centigrade. So just wait, I just calculate the value of RT. So the value is RT is 43.79. After this, you just click submit. So this is the
So,
correct value.
sir, how to get the final temperature?
R0 equals to, sorry, RT equals to R0 into 1 plus
So,
alpha T.
so
RT
alpha into
means
delta T.
that is the temperature difference.
Hmm.
Okay.
Yes, sir.
So here the temperature difference minus 146 degrees centigrade. Okay. So now the value is 43.79. Now again we just press get temperature and the temperature is 696 degree centigrade. Now again I just calculate the value. 367.96. So this is the correct value. We get these values 3 times, and now the temperature is 165 degrees centigrade. So after getting 3 times of value, then click the plot and graph also be generated here. Is it visible? And that is the characteristics.
Yes, sir.
That is the that is the characteristics curve of temperature versus resistance. Okay. Now we go to the second part by clicking level 2. Here are also shown the dynamic characteristics of RTD. So here shows the particular design of RTD. Here platinum used as a bare material. Just select the bare material. This is the platinum, and you just see the left side here also generated the bare material. Okay. Then the nickel iron chromium alloy normally used in manufacturing the RTD sheet because of its inherent corrosion resistance. So now we just select the white sheet, and the material is SS304. This is the food form of the material. This is the nickel iron chromium alloy, and the thickness is 0.5 millimeter. After this, we just select the material of thermal. This is the same material, SS304, and you just select the thickness, that is 1 millimeter. And the thermal which protects RTD from damage by liquid or glass being measured. After this, you just select the filling material, that is the NGO powder. Basically, the NGO powder is used to provide a damping cushion against mechanical and vibration shock. So, in left side, here also generate a RTD. Is it visible, the RTD?
Yes, sir.
Okay. So this is the first part. Now we go to the next simulation part of temperature measurement using thermocouple. Just wait. So this is the second simulation part of thermocouple. At first, we select the type of the thermocouple. This is the K-type thermocouple, and the material used for this K-type thermocouple, that is chromel and alumel. Now select the reference temperature, that is 0 degree centigrade. The temperature range here 95 degrees centigrade to 1260 degrees centigrade. Then click get temperature. Here also show the temperature, that is 116 degrees centigrade. After this, you just click left side, that is the thermocouple reference table. From here, you just know what is the output voltage, that is millivolt of this in this temperature range. At 116 degrees centigrade, the output voltage is 4.756. After this, you just click submit. So this is the correct value. Then again, you just click get temperature. Now the temperature is 326 degrees centigrade. And the output value is 13.290 millivolt. So here also show recalculate. That means the output is wrong. After write down the value, if it is not correct, then here show recalculate and then clicking 3 times submit but simulator, and the simulator shows the correct value. As the correct value is 13.290, but the simulator also calibrates the readings here. So to linearize this curve, simulator also calibrates this value. So this is the actual values. For taking the actual values, we just clicking 3 times here. That the correct value is 12.66. After this, you just submit this, and again you just click get temperature, and now the temperature is 316 degrees centigrade. So now we click the plot and the graph will be generated. So this is the curve of temperature versus output voltage, that is millivolt. Is it visible? Is it visible?
Yes, sir, it is.
Okay, thank you. So that's all. I just share this link in your chat box. Okay, thank you.
Thank you, Mrinmoy. Students, do you have any query? So I think there is no query. So students, now you can understand that sitting at home to perform any kind of laboratory experiment is not impossible. Okay. So now you may heard about the term IoT, that is Internet of Things. Now all the world you can connect through IoT. So it is a very emerging field, and in our department we encourage our students always to do some innovative project. So here students of our department are also present to show you some of their projects on IoT. So now I will request our student Shilpita Hajra. She is a student of 3rd year. Will demonstrate a project of her. Shilpita, please demonstrate.
Shilpita, first come on your webcam.
Hello everyone, am I visible?
Yes, Shilpita, you are visible.
Hello, I am Shilpita Hajra, currently pursuing my BTech degree in the field of Electronics and Instrumentation Engineering. So today I am going to demonstrate in front of you about the IoT project, and it's a very interesting field. So without wasting time, let me demonstrate to you, okay? I think some of you already know that what does IoT stands for. It means the Internet of Things. do you know that what is Internet of Things? Internet of Things refers to a system of interrelated and internet connected objects that are able to collect and transfer or intercommunicate the data over a wireless network without any human interruption. So let me share my screen first. Is it visible?
Yes, Shilpita, it is visible.
So I will demonstrate a project on traffic signal with LED. Yes, we have already seen a project with microcontroller, and it is also with the same concept, but here we are using IoT. So first we need a Arduino. So what is Arduino? Arduino is an open source electronic platform based on hardware and software both. So then you know that inside the Arduino there is a microcontroller. And what is a microcontroller? By name, it suggests that it is very small and it is used in the purpose to control anything. So a microcontroller is a small computer on a single metal oxide semiconductor integrated circuit chip. So what is now a integrated circuit or IC? IC is an assembly of electronic components on a single small piece of a semiconductor metal. So here in this project, here we have a Arduino. We have used two breadboards for connecting as a connecting board. We have connecting wires, three LEDs which will receive the signal, and a LCD display that will show the output message. So let me first simulate it. You can see that the yellow light is blinking and here is the message wait. Now red corresponding it is stop, and again yellow means to wait. Now green signal means now you are good to go. So you may have a query that how it is working. So we have a code that is programmed with this Arduino, and after when we are providing a power supply, it starts working. It sends the message to the LCDs, and according to that, the LCD displays the message, and corresponding to it, the LED light starts blinking. Okay. Let me stimulate it for once again. You may see it. You may see that the USB is now supplied with a power. I request all to make it full screen. You will understand better. Thank you. Do you have any questions?
Shilpita, one of the students asked that, can you please show me the program for the Arduino?
Okay. Just a minute.
Shilpita, wait, Shilpita. Shilpita. Hello, Shilpita.
Yes, ma'am.
Hello, Shilpita. Okay, students, Shantan, actually, I will share the Google Classroom link to you. Okay, in that classroom, we will upload all the programming and coding and flowchart, whatever you need. Okay, we will share after this session. Okay, Shuparna, thank you, Shilpita. Shuparna, continue.
Thank you.
Okay, students. So now another student of EI third year, Samprit De will demonstrate his project on IoT. Samprit, please start demonstration.
Hello, ma'am. Am I audible?
Yes, Samprit, you are audible.
Samprit,
Good af-
on the webcam.
Ma'am,
Okay, if any
I'm
problem, then you
yes,
continue.
ma'am.
Okay, okay,
Good,
okay. You
Okay, Samprit,
good
continue.
afternoon, teachers and my dear students. I am Samprit from EI department, Gurunanak Institute of Technology. I am currently in third year. So today, as my friend Shilpita said, we are doing some projects on Arduino, which is basically based on IoT projects. So today I'm going to demonstrate a distance measurement with the help of ultrasonic sensor and an Arduino Uno. So wait, let me share my screen. Is it visible? Okay, I'm starting the.
Yes, it
Hello,
is
ma'am.
visible.
Okay, ma'am. So basically, it is the circuit of my project. Here, I have used Arduino, a potentiometer, LCD, piezo buzzer, resistance, LCD display, and an ultrasonic sensor, including few jumper wires. So before showing how it works, I want to basically tell how this working principle of this whole circuit. As we know, ultrasonic sensor uses mainly ultrasound waves uh, to detect an object. Wait, I am showing another way. Yes, this is suppose let us assume this is the ultrasonic sensor. It is sending ultrasonic waves to nearby surroundings, and when it strikes an object, an reflection impulse is being transmitted back to the receiver, and it is being sensed. And with this, we can calculate the time taken and the distance uh, to get an approximate distance between the object and the receiver of this sensor. Okay, so this is the ultrasonic sensor in actual. This is the transmitter and this is the receiver pin. From this side, we usually the signal that is transmitting signal is being sent, and from this side it is being received. It has 4 pins. Uh, there are 3 pins also. In this, there is a ground pin. This is the supply pin, and this is the signal from which it will send the Arduino Uno that whether it is transmitting a signal or receiving a signal. This is a LCD display having having 16 columns and 2 rows. This is the piezo buzzer which is being used to create sound. We so that we can understand it is sensing an object. And this is the potentiometer which we are using in our experiment. There are many types of potentiometers, as you can see here. So now I'm going to simulate the program, simulate this one. As you can see, the USB got inside and then signal has gone. As we move the object nearby, the value usually the ultrasonic sensor has a range after which it does not respond. Suppose like this, if we take this object outside the range of the ultrasonic sensor, then it cannot detect any more distance. So you can see that the distance, the last distance it recorded was 332 centimeters or 3.32 meters. And again, if we bring too much close, it will again stop showing because the range is no, it is below the range. Yes. And similar type of application is used in the nature by different types of animals like bat, dolphins. Even in human application, we use this in submarines, in radar, to get the approximate or accurate object distance, which is being used like an radar, similar to radar. I'm showing once more. Ultrasonic distance meter, when we bring it in the range, distance is being measured. Again, thank you. I guess you got my project. If you have any doubt, you can surely tell me. Thank you, ma'am.
Thank you, Sampreet. So students, do you have any query? If you want to anything about this project, you may ask now.
Is there any simulation to design all these circuits?
Yes, can you repeat once more?
Is there any simulation to design the circuits using Arduino?
Yes, there is a website where you can choose whatever components you want to design a circuit.
Can you please share the link?
Okay, sure. I'm sharing it in the chat.
Thank you, sir.
Sir,
Okay. Yes.
can we change the source code to measure a thing that is in a long distance or something else?
No, then we cannot use the ultrasonic sensor for in that case, because this type of ultrasonic sensor and then your other distance measuring sensor, it is limited to a certain range. Beyond that you cannot measure. For those application for long distance, we have to use highly means what you say, that
For the
long distance measurement
for
sensors
the
which
long
are being
distance communication, you just actually we need the radio frequency wave. Okay, so for
yes.
that reason you have to modulate your signal by proper modulation techniques, and then the radio wave frequency, through the radio wave frequency you can transmit your data. So that will be the wireless communication. Okay, you
Yes,
can
from
use this IoT based system at the transmitting end, and after getting the signal you have to do the proper modulation, and then you have to transmit through the radio frequency loop. Okay.
yes, you have to move from ultrasonic waves, because ultrasonic sensors basically uses ultrasonic waves. So you have to move from ultrasonic waves to radio frequency waves for those long distance measurements.
Thanks. Thank you.
Thank you, Sampreet, for your nice explanation. So now I would like to request Mrs. Shantana Das to demonstrate the concept of automation and how virtually it can be done. Please, Shantana madam.
Am I audible?
Yes, you are audible.
Okay, now please give me 1 minute for the presentation to present over here.
Okay.
Is it visible now?
Yes, it is visible.
Okay. Thank you, everyone. Thank you for coming. Dear participants, I will be presenting now the work we generally do in instrumentation and control design lab. Actually, it is 8th semester subject, still we have incorporated to give you the glimpse that how the data may be collected from the real or physical environment, and that will be utilized for the different automatic systems involves in automation mainly. As it is, 3-month course generally, so that's why I'll be giving through the presentation. Okay, so that's why I am presenting the slides. Let's move on. So virtual instrumentation.
Kalpana madam, can you please go to slideshow mode?
Yes, yes. I'm moving. Thank you. Now see, this is virtual instrumentation with LabVIEW. Now what is the software we are generally, simulation software generally we are using, that's the LabVIEW. And LabVIEW is basically the synonyms, that is virtual instrumentation engineering workbench. Laboratory lab means what? Laboratory. Okay. And then VIEW stands for Virtual Instrument Engineering Workbench. And it is obviously graphical based, and as well as I will be discussing what is basically VI. Okay. And just like programming language, we generally use C, C++, basics, etc. In that case, we use general functions, subroutines, right? And so in case of LabVIEW, we generally use VI. Now, move on, what is basically, why the LabVIEW is in DAS. Okay, what is DAS? DAS is basically your data acquisition system. That is our concern. Actually, we are concerning about the real world data. Now, in case of traditional system, what we do? Generally, we set up a sensor and then we generally pick the analog signal. Then we'll transmit it into, using the analog to data converter and different modes. We will be transferring into digital data, and then we will be experimenting with the digital data that will be recorded, that will be transmitted. Now, in case of the automated data acquisition system, what is main concern regarding the LabVIEW I am coming? That is, the sensors transmit a voltage or the current signal that may be in any mode and directly to the computer via the data acquisition board. Now, the software here works. Okay, that is the LabVIEW that controls the acquisition and the processing of such data. Now, what is the benefit? Before coming to the LabVIEW in detail, what is the benefit? Benefit we will get in the automated system, that is the accuracy, as well as the frequency response that will enhance. We much incorporate the large number of frequency as well as value, and the potential to automate pre and post processing and build the quality control such that we can make the control, and that will be very meaningful as well as accurate. Now see, in case of LabVIEW, what we generally have, we have VIs. What is VI? VI means basically virtual instruments. What are the programs we generally do in C and C++? That we generally do in virtual instruments. Okay. So there are two components mainly available, two indoor, that are called two panels. One is front panel, that is the control that consisting of the controls and indicators. Okay, that will be visual in the front panel. And in the backend programming, there is the program, and that will be written in the backend view. Backend view will be basically the programming, and we will be dragging all those components that are available in the LabVIEW browser, through the LabVIEW browser and in the library. So that's why we can collect all those components in a file, and then we will be add all those components. We will be giving certain input module as well as we will be assigning certain output module, and the output and the user friendly as it is. That's why the output and the input that is basically visible over there in the front panel, right? Now, so obviously we have three components over there. One is called front panel, another one is block diagram that we have already done that part, and the connector panel. Now, let's move on. So, what is VI front panel? That it is a glimpse. Okay. So, in the front panel, we observe here the different kinds of switches. Okay, there may be binary switch, there may be analog switch, and there may be certain indicators also. That is for the display, and there may be a certain, suppose oscilloscope will be there, or certain VI, what you can say, the XY graph that we can represent over there. Okay. So there are so many things in the VI front panel that we can execute any kind of the real system that we may represent over there, and the data we actually our main concern is data, so that's why we are collecting the data like this way. Now this is basically backend programming that will be done through the actually the block diagram here. Okay, and here that is designed basically the diagram has designed over there. There are the several kinds of functional tools available. There are the certain constants we can incorporate, as well as certain loops, while loops, sometimes we need basically repetitive recording, right? So in that case, we generally use while loop, as because it has to stop some after certain data, so that's why we are using certain while loop, as well as we can use for loop, and as well as all the data are there. For the data communication purpose, we have the wheres also. Okay, and so there will be the display as well as there will be the input that we generally fed through the input module. Now, what are the palettes that has accumulated? The palettes generally we use for collecting the different input and the output, generally icons, right? You can say better to understand. So here there's the function palette, and this one is the tool palette that is generally used for the automation, for the animation purpose. And we have here also the control palettes. Okay, so here it is not very much more explanation will be there because it is 3-month programming at least. Okay, so here these are the different kinds of controls involved. These are the different kinds of functions involved. Okay, so what are the controls? Numeric control. Then there are the on a button that is binary. Then we have LEDs. So many devices that we can incorporate through these icons, as well as there are the functions also. Different kinds of functions for the analysis purpose we will use. Now, creating here. How to create it here? Just an example I have set over there. So this one is simple addition and subtraction. So we are putting here data as input as A in the variable A as well as B, and that will be according to the block diagram that is given over there. That is the output that will be for the addition and the subtraction purpose. And we are getting, if you run it, if you execute it, if you simulate it, you will get the output. Okay, according to the block diagram, that is at the back-end programming. And in our lab, we will do generally the real-world data that will be actually collected through the DAC, Data Acquisition System card. Okay, so that system card will be installed in the PC, and then we will be basically dealing with the real-world system that may be some kind of water level monitoring, or the pressure monitoring, or the flow monitoring system that may be generally instrumentation engineers are doing in the process of plant. Okay, so that monitoring will be done through the real world signals that will be coming to the data acquisition system card, and then that will be accordingly we will have to design the programming over there, and there is the display unit also. So this is basically the front end. So that's why you can easily it is easily visible that according to the slides there will be the tank level that will be shown over there. Okay, so this is the backend programming. And then in our actually lab view, there's a control system that we generally get, that is the plants loop. Okay, plants having so many relays, so many systems, and that has incorporated over there in a front panel. Okay, that is a real world system, and that has incorporated over there all the readings, all the data that will be monitored or recorded through this front panel only. While the user is not very known to the lab view also, so he or she will be able to monitor all the data, or accordingly the decision can be made. Okay, so it is the for loop designing. So I am not explaining much more as because you don't know what is all the icons over there. Okay, so that's why as much as we use the for loop as well as the while loop, so that's why it is the structure palette that where it is available. So that's why I have incorporated all those loops. Basically, we generally use while loop. Okay, so this is the while loop backend programming, and this one is the for loop program. Okay, this is the flowchart, and you know very well this part. So, but how to do with the lab view? So then you have to consult with us after this program. You are very most welcome. Okay, I will be giving you the software, free software that's available in the net. Okay, so I'll be giving you that link now. So thank you for this part. It is as quite large, that's why I cannot cover everything. Okay, thank you everyone. So I'm giving students, I'm giving you the link. You can download the the software, and then you can execute it. But it is actually it needed actually so much practice as well as learning. It is at least 3 month course as well as it may be extended to 6 months also. So thank you everyone. I am sharing basically the software, free software that is to be downloaded. Thank you.
Thank you, Shantana madam. Students, do you have any query? Ma'am has already posted the link in the chat box, so you can download student version of this particular software, and you can do any kind of automation project through that. Okay. So students, here you saw some of the experiments of our different laboratory. So students, in this short span of program, it is not possible to show you all the laboratories properly. So we arrange a virtual tour to our laboratories. Here you can see the equipment of different laboratories as well as some of our student projects. Okay, so now you will go through the tour of our virtual laboratory. Okay. Paramita madam, are you there?
Yes, I'm sharing my screen so that the students can see the tour for the virtual lab. Okay.
Okay.
Students, I have shared the feedback and attendance link in the chat box. During the tour, you just go through it, okay, and give your feedback, valuable feedback, and your attendance here, okay, and minutely write your name. That will be displayed on your certificate, okay.
Is the screen visible?
Yes.
Yes.
So students, how was it?
Great.
Okay, I think all of you have enjoyed this program. And now we have come to the end of this program, and I would like to request our HOD ma'am, Mrs. Babita Roy, for vote of thanks. Madam, please.
Hello.
Hello. You are audible.
Hello, am I audible?
Yes,
But
you
I
are
can
audible.
share my webcam. I can share my webcam. Okay, wait. Okay. Okay, am I visible?
Yes, you are visible and audible.
Okay, students, am I audible? Am I audible?
Yes, you are audible.
Am I audible?
Yes, you are audible.
Hello, am I audible?
You are audible.
Okay, students. Actually, I think you enjoyed this program. Okay, I have shared the Google Classroom link. We will upload all the documents in that Google Classroom after this session. And I hope you just go through all the links that we have shared in this chat box. And actually, I have already mentioned that you can utilize these concepts, these simulations. You can use while you are doing the projects. And one thing that during this pandemic, I can't welcome you to my college to see all the well-equipped laboratory, but so that we have planned to show you all the virtual tour of our departmental labs. And one thing, students, that you are always welcome if you want to join with us to our department. So I request Shuparna ma'am, the coordinator ma'am, to again share the contact details with them. Okay, and if you want to know much more things about Gurunanak Institute of Technology, you can, Shuparna ma'am, please share the college website in the chat box. They can go through. Okay, and if you have any query, you can ask us. In future also, you can contact with us. Okay, for any query. And if you join with our department, we are always welcome. you come and join, and Shuparna ma'am will basically share all the phone numbers. Okay, students, all the best for your future. Okay, hope you all shine in your very near future, and always try to do something that will basically from your heart, not only from your brain. Okay, and try to do something, try to study something which basically give you mileage in the next few years, not only the next coming 2 or 3 years. You are the student, so you have to go far. So always think for your very far futures also. Okay, so wish you all the best. So Shuparna ma'am, conclude the session. And one thing I would like to give thank all the organizing team, my beloved students who are basically presenting their works here, and also thank you for your patience. Thank you to the students for your patience. Okay, so all the best. And Shuparna ma'am, please conclude the session. Okay.
Before
Shuparna.
concluding the session, I want to show you the certificate which will you get after submission of the feedback. So students, here I am sharing your certificate. We will send this certificate through the mail which we have got from your registration details. Okay. So wait. Is it visible? Is it visible?
Yes, visible.
Okay. So students, you will get this certificate. We will send this certificate to your respective mail ID, which we have got from your registration details. So you have to submit the feedback form and write down your name and all the other details very carefully. Okay. So here we are going to end this session. So now, thank you all. So I request all of you to present. I request all of you to present here in webcam mode. All of you, please on your webcam and come to video mode so that we can take one snap of you.
Government stop.
Mrinmoy, Navamita, so here you can see all the teachers of our department as well as all the laboratory assistants. So student, for any query, I am giving you now the details of contact numbers. So you can contact us. Okay. So now I am sharing this one. So you can go through those contact numbers, and for any kind of academic query, you may contact us. Okay. So now you can off your webcam. So here I am sharing the contact details.
All of you have given the attendance and feedback. It is mandatory for the certificate.
Yes, ma'am.
Is it visible? Is the screen visible?
Yes, visible, ma'am.
Okay,
Okay,
Shuparna
here
can end the session.
Okay. At the end of this document, see here, Mrs. S. Maiti, 94329700012, and Mrs. B. Roy, 9231893138. Okay, student. So for any query, you may contact us. Okay. So thank you, students. Thank you for your patience listening. Thank you all to be present here. Now I am concluding the session over here. Thank you again.